Okay, so today I'm going to teach you about how to determine the radius of an orbit. First of all, you have to know that what Bohr model said. Bohr just took the atom of the hydrogen to determine the radius of orbit. Okay, so first of all, here let me draw here. Bohr took the atom of hydrogen in which the mid one part and this electron. Okay, this was what? Electron which was having negative charge. While in the mid, on that time the proton was unknown. You may see, like उस टाइम पर हमारे पास प्रोटॉन नहीं था. So then on that time we were only having the proton. We weren't having the neutron. Sorry. So here the in the proton we have electron. Yeah, we all know in the proton we have electron. So those are positive electrons. Yeah, we all know. And the atomic number is defined by Z. So atomic number is also known as proton numbers. How much proton are present, we can say these are the atomic numbers. Okay, so mathematically, like here I am writing atomic number. So now mathematically we will be seeing whole that how to find the radius of an orbit. First of all, I am starting from here. Mathematically, you may check. Yeah. So first of all, we all know Coulomb's law, Q1 Q2 upon R square. He took this formula. Q1 F is equal to directly proportional to charges and inversely proportional to radius of square. Okay. After that, if we remove the proportional sign, we put the constant which is K. K Q1 Q2 upon R square. Okay. So here the value of K is basically, we write here K is equal to 1 upon 4 pi epsilon. K is equal to 1 upon 4 pi epsilon. Okay. So here F is equal to K, and here you can see this one I named as Q1, while this one I named as Q2. Okay, as I took here the charges, so Q1 is what? Q1 is electron, Q2 is equal to ZE then, okay, electron in the proton. So now here we have R square. Then if is equal to now E, we will combine K ZE square upon R. After that, now we have to put the value of K. So F is equal to, I can say ZE square upon, what is the value of K? 4 pi epsilon, and here we have R, which is radius square, R square. Now you have to remember this formula. From that we will do further equation. F is equal to ZE square upon 4 pi epsilon R square. Okay, hopefully till that is clear to you. Now we're gonna see that, as you all know, that electron revolve in the circular path. How? Which force hold the electron to move in the circular path? Let me tell you. Electron revolve in circular path. Okay, right, electron revolve in the circular path. Now here the force which is applying, that is centripetal force. So here the formula of centripetal is F is equal to mv square upon R. This is was centripetal formula. Okay. Now here again, now we're gonna compare these both equation. Equation number 1 and 2, we're gonna compare these both equations. So let me compare these. Okay, so here you can see this is F, this is F. So shall I put this value on this F? Yeah, sure. mv square upon R. Then this whole value I put over here, is equal to then ZE square upon 4 pi epsilon r square. Now here you may cut the values which are cutting with each other, you may cut those. So r square r, this is cancelled. Now here mb square is equal to ZE square upon 4 pi epsilon r. Only one r is remaining, one r will be cutting that. Okay, so now here we gonna put the m over here because we have to find, right now we have to find the volume. E square upon 4 pi epsilon rm. Now remember this one formula. Okay, hopefully till that you have understand in very detail. Now we're gonna see that here, as I put here epsilon. You might be thinking, what is epsilon? This is basically permittivity for the free space. Free space. Okay, so now here till that fully this was clear to you. Now we're gonna find the angular moment of electron. What the angular moment of electron? Of electron. This is a momentum. The angular momentum of electron. So yeah, here you can see for that we have the formula V is equal to nh upon 2 pi mr. This is the formula of the angular momentum. Okay, so now we're gonna take the square root of this whole equation by taking square. We got v square is equal to n square is equal to h square upon 2 square, then we got the 4 square pi square m square over r square. Okay, I put only the square root on the whole the equation. Now put the value of v square in the equation third. The value of v square which we get over here, now we're gonna put the value of v square on this one v square. Okay, so yeah, let's put this. V square value was ZE square upon 4 pi epsilon rm. Okay, this is the value v square. I put the value of v square now is equal to n square h square upon 4 pi square m square upon r square. Now cut those values which are cutting. Pi 2, 1 pi cancel, 4 cancel, m1 cancel, r1 cancel. Okay, here you can see what we get. Square upon epsilon is equal to n square h square upon pi 1 because 2 pi 1 was cutted, m2 m cut, r. Okay, we got this one. Now here we're gonna remove this on the that one side because we have to find the radius. Okay, we're gonna find the radius. So yeah, here you can see r is equal to ZE square upon epsilon is equal to n square h square upon pi m. R I put over here. Okay, now hopefully, now let me summarize this. R is equal to cross multiplication, we're gonna do epsilon n square h square upon ZE square pi m. We got the radius of what? We got the radius of an orbit. Still something is remaining over here. Now here you can see here is the r is equal to e n square h square upon ZE square m. Okay, after that here you can see like we're gonna do e square. Now we are removing the constant on the one side while the variables which can be cutted on the one side. So from this whole equation, epsilon is constant, n is number. This is not the constant because the numbers of orbit can be changed. Okay, Planck's constant is Planck's constant h is constant here. Then we have atomic number is not constant, pi is constant, masses are constant. So we are moving the constant on the one side. This whole is constant. Here we have n square upon z square. This is variable. Okay. Now here when we put all the formulas, epsilon, then Planck's constant, pi, then masses formula, we will get one value that is 0.529 n2 upon z square is equal to epsilon. Now epsilon is equal to 10 minus 10 meter. This is the what radius of an orbit. Hopefully you get something new from this video. If you do not get, please watch this video again, share this video, subscribe my YouTube channel. Bye bye.